thank you everyone for being here today. It's the second day of the midterm public workshop. This workshop is part of the dissemination activities of the Interoperate project that it's coming just in the middle of the project that started in 2019 and will last until 2022. We have structured this public workshop with dissemination objectives in two parts. Yesterday was the part one dedicated to end users, and today we are targeting more the technology industry, technologies engineers. So we will have a more profound view of all the solutions that Interoperate is developing. We are together with Stefan. Hello, Stefan.
Morning.
Good morning. We will guide you through the workshop as workshop facilitators, and we will help all the participants and speakers during their presentations. So I hand over to you, Stefan, for the presentation of today's session.
Yes, thank you, Gino. So still with the introduction, let's have a very quick look backwards. So yesterday we dealt with scenarios and data flows. That means that if you look for the motto of the workshop yesterday, we discussed the patient-centered exchange of health records between all parties concerned. And today we will come to the mechanics of the project, which means developing these open interchange protocols. And as Tino just mentioned, we have already made the presentations of yesterday available at this link. And I would also like to rehearse from yesterday that we had a polling process as part of our panel discussion, and we asked for whether individuals, patients would be willing to use this sharing mechanism, and we got a beyond 4.5 rating for the different questions with a just small, a little bit lower on research. And we asked whether health professionals and researchers would like to use the data, and had a likewise positive rating. And the keywords that were mentioned were trust for the first question and availability for the second. And from the panelists, what I noted as a kind of take-home message is that the approach of Interoperate is sensible, and it comes at the right moment. So with this, I would like to forward to Matteo. Maybe I can just mention that the workshop, like yesterday, will last 2 hours. And we will now have a quick introduction from Matteo Melideo, our project coordinator who works at engineering in Italy. Morning, Matteo.
Good morning, everyone, and welcome also to the new ones, to the day 2, those that yesterday was not able to participate, My talk will be very, very short because I want to leave you to listen to my colleagues' technical presentations. Just to say, in addition to what already Tino and Stefan said, that Interoperate, for those who were not present yesterday, Interoperate is a European Commission initiative which was funded under Horizon 2020 project, under the call which was aiming at prototyping a European electronic health record interoperability. In this respect, as said, the consortium is composed of 16 partners belonging to ICT solution, healthcare solution provider, hospital, universities, research centers, and as well as European and local stakeholder associations from 7 different countries. Again, as you will see in the next presentation, the idea is to empower citizens, making them a vehicle to more easily share data among healthcare stakeholders, and basically making them, providing them the possibility to keep relevant health data in their hands, thanks to a smart electronic health record which can be installed on a mobile device. In this way, basically, we want to make the citizen, as I said, a vehicle to share data easily with the healthcare professional, but also enable this a so-called interoperability data economy. In this respect, what we want to provide is not yet another software platform, but rather specifications, guidelines, protocols, which will be then made publicly available to the community to build on top of these other solutions which can be compliant with this regulation, which can somehow enable the development from other players of smart electronic records, which, according to well-defined standard, for instance, HL7 will be able to, again, provide these additional services to citizens. Okay, this is just a very short introduction about the project. I do not want to say more than this, to not take time to my colleagues. I hope you will enjoy the rest of the day, and that you will ask us a lot of questions, comments, criticism in order to improve this project that I think could provide a very valuable contribution to the European Union. Thanks a lot.
Thank you very much, Matteo. So we are going to start with the first presentation, Architecture for Decentral Health Data Sharing, that will be provided by Francesco Torelli. He's the Interoperate Technical Coordinator, also working in Ingegneria Italy. Good morning, Francesco. Please, the floor is yours.
Can you hear me? Can you hear me? Okay, okay. Good morning to everyone. Thank you. So I will start with the first slide. Okay, as Matteo said, the main objective of Interoperate is to support the cross-border exchange of health data. In particular, we focus on the exchange of data between the citizen and other European organizations. How do we want to do? Again, as Matteo said, we mainly want to specify protocols for the specification. As we will see in the next slide, we will specify 3 different protocols to support 3 different usage scenarios. A particularly important element of these 3 protocols is what we call SERC, that means Smart EHR. Smart EHR is a mobile application, any mobile application that is able to store the health data of a specific citizen on a mobile device of the citizen, and is an application that is compliant to a set of rules specified by our project. So it's not a specific application that can be provided, different application can be provided by different vendors, but all these applications, in order to be considered smart EHRs, must fulfill this set of rules. As I was saying, the main results of the project are an open specification containing the design of these 3 protocols and the rules that the Smart EHR has to fulfill, and also a reference implementation to demonstrate that the protocol can be actually implemented. Next slide, please. So I was saying the main results are the specification of 3 communication protocols. Every communication protocol satisfies a different scenario. In particular, we define what we call a device-to-device protocol, or D2D protocol, that is intended to exchange health data between a citizen and healthcare professionals healthcare organizations without the usage of internet, but just using a Bluetooth connection in order to guarantee a higher privacy to the citizen and also allow the exchange of information when the internet is not available. We apply this in particular to a scenario of a medical visit abroad when a citizen is in a foreign country and needs healthcare, but this of course can be used also within the same country of the patient. The second protocol specified by the project is called remote to device protocol or R2D protocol. In this time is an internet protocol. This allows to import the health data from any organization in Europe that fulfill our specification. This protocol also allows to back up the content of a setup, the health records of a citizen on a private cloud selected by the citizen. So the citizen can choose its preferred cloud provider and store their data on this cloud. This is important because can be exploited in by professionals.
Gerol, please mute the mic. Please mute the microphone. He's not talking, please.
Thank you. Can be exploited by the healthcare professionals to access to the data in emergency situation. And finally, we specify a third protocol for supporting research studies. Thanks to this protocol, it's possible for the citizen to donate its own health data to specific research studies. Next slide, please. So other than the specification of these protocols, we also specify this set of rules for the SER mobile application and SER cloud services that are called SER conformance level. All these protocols are based on the HL7 FHIR standard, that is a new standard for the exchange of health data. And we specify specific profiles for this exchange of data. Next slide, please. Okay, as I said, we also release a reference implementation. This reference implementation contains a prototype for each one of the main elements exploited by the protocol. So a prototype of SER mobile application, a prototype of cloud services, a prototype of application for healthcare professionals that we call ACP app, and a prototype of services for the research and for the health organization. Next slide, please. We also provide a set of tools that can be exploited by the healthcare organizations for converting their legacy data to the common profile, the common FHIR profiles that are needed by our communication protocols. These tools can also help the healthcare organization to translate the data in the language of a specific user, in the language of the healthcare professionals of that country. Next slide, please. Okay, this slide is just to give an overview on all the elements of the specification. Actually, each one of the protocols include just a portion of these components. So not all the components are being needed for every protocol. Every organization, every application provider can decide to support just one or two protocols. It's not needed to support any protocol. But this picture shows all the elements involved in all the protocols. As I said, we have the main component that is the SER mobile application used by the citizen. Then there is the SER cloud service that can be exploited by is an optional service, so the citizen can also decide to not use any cloud service at all. Our protocol are able to work also without the cloud services. And the other important element, of course, are the element needed for the research protocol. In particular, for exchanging health data with other with the research organizations. There exists what we call a research network central node, a central node where the research organization publishes the description of their study. The citizen can access this repository to look to the description of this research studies and decide if to participate or not, and then can exchange of data. Every protocol, next slide please, every protocol involves several interfaces. In the slides, I just show you very quickly the main interfaces involved by every protocol. The device-to-device protocol, that is the protocol for the exchange of health data without the internet, involves two interfaces that are called MD2DI. M stands for mobile, so it's mobile D2D device, device-to-device protocol, and terminal device-to-device protocol, TD2D. That is the interface offered by the terminal of the healthcare operator. So in order to exploit the D2D protocol, it's needed that every party, the healthcare organization and the mobile application, implements these interfaces. Next slide, please. For the R2D access protocol, that is the protocol that allows the citizen to import data at distance using the internet from every health organization in Europe, we have to use the healthcare organization has to offer an interface that is called R2DI. This interface, as other ones, is based on the FHIR specification. In these protocols are also involved the ADAS infrastructure. We allow the citizen to log in also in foreign countries, just using his own national identity provider. So he can use the same credential all across Europe to import data from different sources. Next slide. Another important protocol is the protocol for backup the information on this optional SerCloud. In this case, the SerCloud provider has to offer two different interfaces that are called R2D Cloud Reader and R2D Cloud Writer. One is used by the citizen to write the information on the cloud. The other one is used by the healthcare organizations, in particular in the emergency situation, to access the data in a secure way, in a trusted way. Next slide, please. And the last picture is just shows the components and the interfaces involved in the protocol for the exchange of research data that is called RDS protocol, Research Data Sharing Protocol. These protocols involves, as I said, the research central node where the research studies are published, the description of the research studies are published, and of course the research organization, the systems of the research organizations that wants to receive the data from the citizen. Each one of these organizations has to expose a different API, again based on the FHIR standard, for exchanging the information with the citizen. It's involved also in this case the ADAS infrastructure and another organization that is able to provide pseudonyms for anonymizing the data of the citizen. That's all. It's just a very, very quick introduction. In the next presentation, you will see more details on each one of these protocols. Thank you.
Okay, then thank you, Francesco, for this really very nice overview. And as Francesco already mentioned, we will see more details now in the upcoming presentation. So if you just look in bird's eye view, oh, Tino, can you just stay on this page? Over the agenda, you see that these acronyms D2D, R2D, R2, RDS, that they will reappear now in the next three upcoming presentation. So now I hand over to Thanos Kurtis from the University of Piraeus Research Center in Greece. and he will introduce the interoperate D2D protocol, which enables secure peer-to-peer exchange of structured health records between patients and healthcare professionals today by the means of Bluetooth. So, Thanos, it's yours.
Thank you, Stefan. So, hello, everyone. This is Thanos Kurtis. I'm from the UPRC in Greece. And this will be the presentation of the device-to-device protocol. So, regarding the user's problem, it should be mentioned that currently we live in the healthcare sector where there exist several terms such as APIs, blockchain, or machine learning, where all of them promise to solve the challenge of maintaining and facilitating the exchange, sharing and analysis of healthcare information. Due to the aforementioned, currently medical information can be found and, of course, is usually stored until today on papers, and when it has to be shared between healthcare ecosystem entities, this can happen usually by mails, faxes, or by the patients themselves, who often bring the files from appointment to appointment. This, of course, has as a result to exchange most of the times, not all the times, but most of them, to exchange inaccurate information, which could lead to inefficiencies, increased errors, increased costs, and care of low value. Due to the aforementioned, we have the hospitals that demand and say that currently there exist inconsistencies in the information that is being exchanged, since health records cannot accompany citizens during the physician's visit. On the other side, we have the physicians themselves who complain and say that the right data is not at the right time, and so providers cannot make the appropriate and right decisions. And finally, of course, there is the side of the citizens who are not able to participate and contribute in the way they want actively in their own healthcare. Next slide, please. So, in order to address the aforementioned, in Interoperate, we are focusing on the medical visit scenario, as it was described briefly previously by Francesco, where in our case, in the Interoperate side, we're providing the citizens the ability, using only their smartphones, to be able to travel along the European Union with the health data, to store their data locally on their smartphones and exchange their data even in cases where internet connection is not available. And in that case, we have a device-to-device protocol which can make this happen, meaning that the citizens and the healthcare practitioners can exchange healthcare data using the Bluetooth protocol. So this will be the specification of the device-to-device protocol, which will be described in the upcoming slides. Next slide, please. Okay, so regarding the device-to-device protocol, as a high-level specification, we can see here a simple to understand and follow figure where we have the side of the citizens, the patients in our case, and the side of the healthcare practitioners, the HCPs, or the local doctors, we can call them as we want in this case, where both parties, regarding the device-to-device protocol, can communicate with each other and exchange messages. This communication can happen on top of the Bluetooth short-range distance data exchange protocol. So the two involved parties have to securely connect to each other using Bluetooth, and then they are able to exchange identification data, to exchange healthcare-related data in the form of HL7 file. Of course, it should be mentioned that all this communication happens on top of an encrypted channel and Bluetooth channel, and everything is secured due to the fact that we are also focusing not on only on the exchange of data, but also on the security of data exchanging. And finally, the two involved parties are able to exchange evaluation data and close the connection in the very end. So regarding the novelties of the device-to-device protocol, it is based on a globally used short-range distance data exchange protocol, which is Bluetooth in our case. It is compatible by the main market operating systems, since we are using different Bluetooth profiles for having the communication between Android, Apple devices, and Microsoft devices. And of course, it provides the D2D protocol provides a secure and easy to use data exchange process that requires minimum user interactions and has fast response times. Okay, so the D2D protocol has been specified into 5 different categories, which I'm going to mention right now. So the first category has to do with the overall connection process, where, as we can see in the next slide, we have the 2 applications. These figures are from the demonstration of the device-to-device protocol and the medical visit scenario. So supposing that we have the healthcare practitioner application on the very top and the smart EHR application on the below of your screen, we can see that on the very left, both the applications are able to open the connection, to initiate the connection. As soon as the initiation of the connection takes part, then we have the HCP application that automatically generates a QR code where the smart EHR application has to scan this QR code using the camera of the citizen smartphone. And after the scanning of this QR code, after a few seconds, we have the successful Bluetooth pairing and bonding process between the 2 involved devices of the citizen and of the healthcare practitioner. In the next slide, we can see. Sorry, on the next slide, we can see the second phase of steps, which has to do with the identification of the 2 involved parties, where there is the exchange of demographic data between the citizen and the healthcare practitioner. As we can see on the next slide, that includes the figure of the demonstration. Okay, we can see on the left-hand side the screen of the smart EHR application, and on the right-hand side, we can see the screen of the HCP application. On both screens, we can see the exchange demographic data that has been exchanged between the 2 involved applications, where on the smart EHR application, we can see some details of the healthcare practitioner in order to be identified from the side of the citizen. So we can see the name, the surname, or the healthcare organization of the healthcare practitioner. And on the other hand, we can see on the healthcare practitioner's screen the data which has been sent from the side of the citizen. So we can see the first name, the family name, or the ID of the patient. So in that case, both the involved parties have to accept what they are seeing on their screens using the D2D protocol. And in the case that both parties agree, then we go to the next step of the device-to-device protocol, where we have the consent exchange. In that phase, in the phase of the consent exchange, we have the healthcare practitioner who demands, who sends to the citizen a specific consent, which has to be approved from the side of the citizen, in order for the healthcare practitioner to be able to have access to the citizen's data. So, as we can see on the next screen again, on the next slide, we can see on the side of the smart EHR application a short message that contains a single.
Weiter als Deutschland.
Sorry, can you mute?
Ja, waren jetzt ausgekriegt, dass das machen möchte, irgendwann mal 34.
I'm hearing voices. Okay, so on the side. I was muted now, okay. So now on the side of the smart EHR application, we can see the consent that has been sent, the consent form that has been sent from the side of the HCP, where the citizen reads this consent and agrees or disagrees, depending on if the citizen approves or not. So in order for the overall process to continue of the device-to-device protocol, the citizen has to agree with this consent in order to go to the next category. Next slide, please. Okay, so the next category of steps, no, the previous one, slide number 35. Okay, so the next category of steps includes the healthcare data exchange, where the citizen exchanges healthcare data with the healthcare practitioner in order for this data to be visualized in the healthcare practitioner's application. So if we go to the next slide, we can see again the two different screens, and on the right screen, of the healthcare practitioner's application screen, we can see that the healthcare practitioner is able to have access and visualize on his own application, on his own device, for instance, the allergies and the intolerances of that specific citizen. So the healthcare practitioner visualizes this data, and as soon as he's making the examination that has to be performed, then the healthcare practitioner sends back to the side of the citizen evaluation data. And finally, as soon as the evaluation data has been received, we have the final set of steps on the next slide, where the connection between the two involved parties can be terminated. So if we go to the next slide, we can see that both parties can at any time, but at this specific time, can press the close connection button, and the overall Bluetooth connection is terminated. And this was the ending of the device-to-device protocol specification. In the next slides, we can see that we have, of course, apart from specifying the device-to-device protocol, we have also implemented two different Java libraries in order to implement the functionality of the protocol from the side of the SmartHR application and the side of the HCP application. So from the side of the SmartHR application, in the previous slide, we can see that there exist several components that we have been developing, such as the security-related component, the Bluetooth connection component, or the data exchange component. And of course, we have made use of some external libraries, speaking about the HappyFire library for exchanging file data, and the Android Bluetooth API for performing the overall Bluetooth connection. The same process has been performed in the next slide for the healthcare practitioner, where again we have designed and implemented a specific library for the healthcare practitioner's application, where again we have security-related components, data exchange components, and external libraries such as the HappyFire library and the BlueCove library. Finally, regarding our next steps, regarding device-to-device protocol, we want to add the option to citizens in order to send partial information upon a specific request of a specific HS7 file resource. Of course, we want to add additional operations in order to transmit additional kind of healthcare-related data, speaking about medical images, because actually we are exchanging, let's say, vital signs lab results, but we are currently working on exchanging medical images, which is the most challenging part, since they have large numbers of megabytes. They are much bigger than simple lab results or evaluation results. Moreover, we want to specify the D2D protocol in a more independent way in order to avoid mandatory one-to-one interactions, such as the one ping-pong interactions that I was mentioning previously regarding the device-to-device protocol specification. And finally, we want to test the D2D protocol with additional short-range distance communication technologies, such as Wi-Fi Direct, apart from Bluetooth, in order to perform an overall evaluation and have a better view of what technology should be used and implemented in our case. So this was all from my side. Of course, there are too many details to say in just 10 minutes, but in any case, in this slide, you can see that we have specific deliverables of the Interoperate project, where you can see the overall D2D specification, the implementation of the libraries, and a demonstration of the libraries implementation. So thank you for listening to me. I'm happy to answer to all of your questions.
Okay, thank you indeed, Thanos. So the floor is open for questions. Our team, Mark and Luc, monitoring the chat. Do you think that there's something that we can bring in here as a question?
Hi, Stefan. There are quite plenty of questions. Some are very, very specific. One comes probably from Diana from Siemens Healthineers, which is about the SDPI FHIR community with a proposal to connect with this community to align roadmaps. That's one point on which perhaps Francesco could answer if we have an answer.
And Diana, if you would like to open your micro and address us directly, feel free to do. But we have spotted you.
Yeah, first of all, I really like the project and congratulations for what you have been doing so far. And I think that the activities that have been going on FHIR, and especially with this Gemini community with IHE and HIMSS, are really aiming for finding a single specification on FHIR for the communication of the devices and also IEEE. So that's why I was pointing into this direction. So definitely might be that the use case that has been mentioned this morning is not covered yet there. And if you have been already finding a solution for it, it is good that you bring it over there and you say, this is what we had been thinking about, and this is our FHIR proposal, so that they don't need to redo it again. And that at the end of the day, is just that the communities talk to each other, and not that if in 2 or 3 years they say, oh, we have this use case, and they come with a total different solution, and then we again fail on interoperability. So I think that the efforts that are being done here are definitely good, and if that should be the way the other people should be implementing, we should also be spreading the word. So that is just my comment.
Okay, thank you indeed for this message. Francesco, do you want to add something, or is it? You have to unmute your micro.
Can you hear me?
Yes.
Sorry. Okay. I think it can be useful to clarify the different goals of interoperates and the initiative mentioned by Diana. I'm not an expert of that initiative, but their main goals is to allow application of healthcare organization to import data from medical devices, from devices that measures parameters of patients. In our case, the goal is different because we have to allow the exchange of data with the SER mobile app, with this application of the citizen that stores not just the measurements of the patients, but any health data produced by any source, so by any organization, by laboratory tests, and so on. Moreover, in our case, the exchange of data is bidirectional. With the medical devices, it's mainly needed to read the data or to write some configuration parameters. In our case, instead, the physicians must have the capability to read and also to share with the citizen different data. So, but sure, we have to try to reuse FHIR profile, some of the FHIR profiles specified by this other community. But the goals are very different, so there is low risk of overlapping to reinvent the wheel.
I mean, it's not it's not just that they're reinventing the wheel, it's just that I said here, it's also IEEE also getting involved and so on. So they, as you are mentioning, that there is Bluetooth connectivity and so on, so that this layer of communication is also getting addressed in this what they call cathedral of standards and so on. So that's why it was thought.
I try to change the connection because I have problems.
Okay, Diana, I think that your point was made very clearly. And I think it would be worthwhile to follow up also
Exactly.
this approach and you and this organization after this workshop. Okay, so
I see another question, Stefan. If we have still 1 minute, another question that would be a bit of different nature that could also be useful.
Okay.
And that comes from Olivier Dion, who is asking a question about consent. Where the consent
okay, I was tempted to go on with the timing.
Sorry, I was not able to hear the comment of Diana in the next words. Sorry. So in case it's needed, please repeat.
No additional answer right now needed. We have now one question which has just forwarded by Mark from the chat. Where is the consent stored?
Okay, the consent is all the protocols exchange. It depends from the protocols. In the case of the D2D protocol, the consent is shared on the mobile app of the citizen, and of course, it's up to the healthcare organization to receive these consents, and the storage depends from the procedures, from the organizational rules of the healthcare organization. We just specify the communication protocol. We don't give, we don't change the rules of the healthcare organization.
Okay, thank you. So Tino, you would like to introduce Alessio?
Yes, thank you, Stefan. So the next protocol, the R2D, will be presented by Alessio Graziani, working in engineering Italy. Alessio, you can see that the question and answer session is very interesting, so I encourage you to go quick to the presentation and have some time for Q&A.
Okay, just a moment that I start the timer, so I won't be late. Okay. So in this presentation, we are going to talk to other protocols, to other communication protocols defined by the Interoperate project. Differently from the previous presentation, these protocols works over the internet, and their name always starts with the acronym R2D, where R is for remote. And today we will talk a little bit about three protocols that fall under the name R2D, and they are the R2D access, the R2D backup, and the R2D emergency protocol. So as you can see from this slide, the R2D access is the protocol used to import data, health data on the smartphone. So by using this protocol, I can connect to an hospital, to a private laboratory, and download my latest laboratory exam analysis, or my latest blood analysis, and so on, and import them into the mobile phone, and collect into a single point as the mobile phone all these health data coming from different sources. While the R2D, the backup is the protocol used to automatically and periodically backup on the cloud this little treasure that the citizen has collected on his phone. And then finally, we thought that this data stored on the cloud may be very useful in case of emergency, especially if the patient is the citizen, is abroad, is not in his country. It may be very useful to other ACP, to other doctors working in an hospital that may access this data in an emergency situation. So this is the general vision of the three protocols, and I want just to say that we are working on the R2D access from the very beginning of the project. So the R2D access has more or less 2 years of work We are working on the R2D access more or less from 2 years, while R2D backup and R2D emergency, we started work on them at the beginning of this year, so in year 2, and they are objectives of year 3. So all this was just to say that we have much to say on the R2D access than on the R2D backup and emergency. Okay.
Alessio, just we heard the timer very close to the mic. If you can put it a bit far from the mic, we will appreciate. Thank you.
You think that there was a bomb inside my? Okay, excuse me. And okay, so this is a general view of the 3 protocols with an high-level architecture, where we can see that at the center of everything there is the smartphone of the citizen, where the setup is running. And on the left, there are the R2D providers, where we have hospital, national EHR system, private and ACP, or general practitioner. They both, in this vision, they should all provide they should provide an R2D API, so they should be compliant with the R2D protocol. It means the data that they collect are available to be downloaded by the patient using the R2D access protocol. While we can see that the other components in these architectures are the family of the SareCloud providers. It means that there are different providers where the citizen can backup his data. They all are compliant with the R2D backup or cloud API that we saw before. And by using this API, both the citizen can backup his data using the R2D backup, and the hospital also can access this data in emergency situation. Okay, so we will start talking now about the first protocol, the R2D access protocol. It is a read-only protocol. It's completely based on FHIR, and it means that not only the data returned by the protocol are structured with FHIR structures, but it means also that the way we submit requests to an R2D server, it's based on the query language defined by FHIR and called FHIR RESTful APIs. So it's completely based on FHIR, but we defined our own profiles for modeling the data, and we applied some constraint and restriction to the APIs in order to simplify the query language to request data. And a very important thing that must be underlined is that the user authenticate himself using the European standard named eIDAS. So the user does not require to register or to use a different authentication mechanism when he connects to different R2D access provider. He always uses one single authentication mechanism, that is the authentication mechanism provided by, defined by eIDAS. Okay, next slide, please. So, in the next 4 slides, we are going to see how the R2D access is perceived by the user of the R2D access. That it must be remembered, it is not only used by citizens, it will also be used by developers while developing apps. As Francesco said in his presentation, in Interoperate, we are defining open specifications, and the specification of the R2D access are fall under this category. but we are also defining the interoperate framework. In this way, it must be said that for what concerns the R2D access, the framework is composed by a mobile library that can be used by developers of apps, and by using this library, developers does not need to know all the technical details of the concrete protocols used. So, in this first slide, we are going to see a real screenshot taken from the Andaman 7 application, and that shows the 4 fundamental steps in an R2D transaction. So the first step is the initialization, where the patient chooses what is the hospital where he wants to download the data from. The second step is the eIDAS authentication. The third step is the concrete download of data. And the fourth step is the storage of this data on the mobile phone. And the screenshot shows some sample data that have been downloaded and stored on the phone. So in the next slide, we will see how these, we will see always this transaction, but from different point of view. So from a conceptual point of view, with this sequence diagram, we see that the health application uses the mobile library called the mobile R2D to execute both the login and the request to the R2D server. So the interaction with the eIDAS and the R2D server is hidden by the library, is hidden to developers by the library. And this is a schematic view of the transaction that we saw before. We can go to the next slide. And what happens when the mobile library submit a request to an R2D server? It happens that operations, abstract operation defined by the library are converted by the library into concrete calls to the R2D server. So in the case of this slide, we see that the get last record method is used to retrieve the most recent version of laboratory results. So in this case, the app is requesting the most recent version of the last laboratory result executed by the user, and this method is converted into the RESTful invocation that we saw before. And if someone of you is confident with the HL7 Fire RESTful API language, you can see how this is translated into a RESTful operation compliant to the Fire RESTful API. Okay, so every operation exposed to developers is then converted into a concrete operation of the protocol. The snippet of code that you see here is a real one. Everything that you saw in this slide is real, has been taken from source code of the project or from the app developed in the project. So as you can see, the first instruction is the initialization, corresponding to the initialization. The second one, where the invocation of the login, is the authentication. The third one, the get last records, is the download phase. And here it is missing the storage, but anyway, I think that it's quite easy to understand how a transaction with the R2D works. So, for what concerns the next steps, we are going to clarify the relationship with other standards that are very similar, that have a lot of things in common with the R2D, and they are the mobile health device defined by IHE, and also the EPA project by HL7. And in our view, we suppose that we are going to change some definition of our of the R2G access protocol in order to be compliant also to MHD. This is the idea that we have now. And for what concerns the support to specific health type of data, we will add the support for prescriptions and for diagnostic report containing DICOM images. While for what concerns the R2D backup and the R2D emergency protocol, I just want to say the basic principle of these two protocols, because I think that I'm a little bit late. The R2D backup is the protocol used to backup data of the citizen, health data collected by the app. The main idea behind this protocol is to completely hide everything to the cloud provider and not rely on mechanism, encryption mechanism and security mechanism provided by the cloud provider. So we really want that the cloud provider does not know anything about the kind of data that are stored on his cloud. And in this case, we are also not using eIDAS authentication because we don't want that the SerCloud receive eIDAS token that may be used to read some data of the patient, of the citizen who is performing the operation. So we provide in ad hoc developed encryption mechanism that is performed by the SerApp using a private certificate of the citizen, and we just send to the cloud provider already encrypted data in such a way that the cloud provider is not able to determine what kind of data he is managing. Okay. So here we have the same structure that we saw before. We will realize the mobile library, providing a method that will be translated into HTTP operation, so to facilitate the development of mobile app for health. And for what concerns to the emergency, we must say one thing that is very important. Once that the citizen has stored his private data on the SerCloud and the cloud provider is not able to read them, how can an ACP access them in an emergency situation? He can access them because we thought one simple mechanism based on a card owned by the citizen with a QR code printed over, and the ACP, in case of emergency, can have this card, can scan this card, and can gain a temporary access to the SerClouds and download history or download history of the patient, or download the patient summary or other relevant data that he thinks that may be useful to better understand what is the health status of the patient. And it must be said that also the ACP has to authenticate, because on the SerCloud everything will be logged, and the temporary access will be closed at the end of the emergency situation. So I finished. I've been very fast, and I tried to be on time, but I think that I failed.
Stefan?
So I don't know if there are questions and an answer.
Okay, I think we yes, thank you indeed, Alessio, and yes, we are now 10 minutes late overall with the agenda. Of course, you started also late. So not sure whether there may be one question that we can put forward here. I actually didn't spot anything that was directly related to this protocol family.
I can confirm your
hear...
analysis, Stefan. I didn't spot any questions. Questions have been, conversation has been continuing on the chat, but related more to the earlier presentation.
Just maybe for clarification, Mark, just the question of the large volume of data, which has been publicly and privately answered on the chat, but I think it would be nice just to have an overall clarification on that, Francesco.
Sorry, can you repeat?
Yeah, can you clarify just, well, what the question raised by Lucia was say, what happens when you have a large amount of data if the patient still needs to put all those data on their mobile, but there is a limit to that. Can then the healthcare professional do it directly, or what is the solution?
Yes. Okay, we have our scenarios are evolving. We will produce a third version of our scenarios in the third year. For this year, we already included the possibility for the healthcare professionals to write on the SER cloud of the citizen during the emergency situation. So using this possibility, it's possible also to upload large files. We are considering to include these possibilities also during the medical visit scenario, for example, for large images, for allowing the citizen to have a copy of large images. But in any case, the citizen, there are also other possibilities. There are certain healthcare organizations that already offer the images using a DICOM API. So another possibility that we are considering is just to allow the citizen to access the DICOM API of the healthcare organization. But there are pros and cons for every solution, so we are considering that. Please.
Yeah. Thank you, Francesca. I would like also to comment that it's usually misconception to say that there is so much data in electronic health record. Most of the time it is not. For example, in the current SER app, Andaman 7, we can store a lot of information, or really everything from the patient, including images. What is important also is the text protocol that goes with the image. So this is even more important than the images themselves. And then for all kinds of extremely large documents or data sets, like very big images, it's not practical to move them around the internet either, right? So usually those solutions include some kind of portal, imaging portal. And so the solution that we are considering here as part of the consortium is to move the pointers to these web portals and possibly access codes and temporary access codes, like there are some already on several products on the market. And so the patient will still have all the information, the text protocol, the access code, and possibly a pointer to a file where it resides. And sharing that with his doctor will allow also the doctor to have access to the document online. That's one of the ideas. But in general, you can really store a lot on the smartphone. Really.
Okay, there's just a question coming in, which I think it's also quite interesting, from Joao from SPMS, which is the service provider that the patient authenticates against in the access use case. Is it one of his country of affiliation?
Yes. We use EIDAS. EIDAS means that the citizen uses the identification services offered by the country affiliation of the patient. It's always the same.
Good. So now let's move on. We are now coming to the last in the family of protocols, which is the interoperate research data sharing protocol. And happy to give the floor to Gabor Bella from the University of Trento in Italy. Gabor, it's your floor.
Hello, everyone. Good morning. So I'm going to talk to you about the protocol we designed about research data sharing. So yesterday, Stefano Damiani already gave you an overview of this protocol, so I will just start with a quick reminder and give you a bit more technical details. So quickly, the protocol addresses two main challenges in cross-border medical research: the data heterogeneity problem and the data collection problem. And the heterogeneity problem is about the fact that each EU country has its own language, it follows its own data representation conventions, has its own policies with respect to security and privacy, and its own IT implementations, of course. And interoperation on research data has to happen despite these differences. And on the other hand, the data collection problem is, as it was mentioned by Stefano, is about having access to more patient data, about making it easier for citizens to provide these data, and at the same time give them more control over their consent to participate in studies. So next slide, thanks. Well, in one sentence, the solution that our project provides is that research data are collected directly from citizens' smartphones residing in multiple countries in a secure and anonymous manner, following explicit consent by the citizen. So this solution addresses the heterogeneity problem by the adoption of a set of healthcare standards, including FHIR, and this set of standards we call the interoperability profile. And we use services and tools for data conversion and translation that make use of this profile and make it feasible in practice. And our answer to the data collection problem is the smart EHR that resides on the mobile device, and through which citizens can give consent or revoke their consent for each study separately. And then they can share their data remotely. And so these, I highlighted the 3 points of our solution. Actually, one of the highlights is missing, but anyway, that we consider as innovative. So firstly, the direct collection of data from the smartphones. Then secondly, that this collection is happening across the border on data originating from multiple countries. And thirdly, that the citizen is given this possibility to give consent to each study separately. And this protocol was actually primed by the innovation radar of the Commission this year. Yeah, we can skip this slide actually. Yes. So to enter a bit more into the detail of what the protocol covers and what it doesn't cover. So because as you know, the medical research process is a very long and complex process that starts from the definition of a study, then its acceptance by an ethical committee, and then data collection and so on. So we in Interoperate only cover a part of this process, namely the parts that directly involve citizens. So concretely, we specify and implement the following steps. So the citizen opts in to receiving notifications about studies in which they can participate. And then if the citizen has opted in, then his or her mobile device regularly downloads the machine interpretable descriptions of available studies and silently checks whether the citizen is eligible to participate. So, for example, has the corresponding medical conditions. If the citizen is eligible, then he or she can give or refuse consent to participate. If the citizen gives consent, then data will be automatically retrieved from the smartphone as required by the study. And finally, the citizen can at any time withdraw from a given study and also opt out from participating in future studies overall. So the process I just showed is divided into two main parts, two separate communication interfaces. The first interface is for downloading research study definitions. So this is done by accessing a so-called central node of the research network. You can see it on the upper right corner. So the central node contains the descriptions of studies that have been officially approved and published, and they are also digitally signed to prove their authenticity. So the smartphone regularly downloads these studies published on the central node and checks whether the citizen fulfills the enrollment criteria to participate in each of the studies. Yeah, please go on. Next slide. Yeah. The second interface of the protocol is for sharing data, actually. So if the citizen decides to participate in the study, then each citizen will be attached to a so-called reference research center. So in multicentric studies, there are multiple research centers participating, and each citizen is attached to just one of the centers. So the consent of the citizen, which is digitally signed, is sent to this reference research center through the protocol. And then through the duration of the study, the phone regularly retrieves health data, anonymizes and pseudonymizes it, and sends it in encrypted form to the reference research center. And finally, the withdrawal from studies is also happening through this interface, because the reference research center obviously needs to be informed of the withdrawal. Next slide. Yeah, so this is my last slide. So on the right hand side, you can see the protocol specification, but I'm not going to present it. You don't need to read it. This slide is just to give you an overview of the technologies we use for the protocol that we consider innovative. So first of all, the use of FHIR. So the adoption of FHIR allows us to define research studies in a machine interpretable way and run them on smartphones. It also allows data harmonization, cross-border retrieval. The semantic mapping and conversion is applied to data. This is also a prerequisite for cross-border interoperability. Encryption and digital signatures are for the secure and trustable transmission of consent and data. And finally, the fact that pseudonymization and anonymization are applied already on the phone is a strong guarantee for privacy. And this is it. Thank you very much for your attention.
I was muted. Thanks a lot, Gabor. Okay, time is really flying now. Unless I will be interrupted, I think we have to immediately go on with Simone. And I'm wondering whether we may even decide to skip the demo, the film in the presentation of Simone. But it's your...
Yes. So welcome, Simone. The floor is yours, and you can reduce the time of the video playing, will be good.
Okay, yeah. Hello, everyone. We can maybe skip some parts of the video in order to be more quick. So yeah, hello, everyone. This presentation is about the semantic mapping tools provided by Interoperate. And I will explain you the usage of these tools as well as the features of these tools. Let me start from the context in which these tools live. It's an European context in which each country represents the health records through different data formats and involving different medical data standards and, of course, different languages. Which is the problem we want to provide a solution to in this context. We want to allow the citizen and the healthcare professionals to consult the health record translated first of all into their own languages and converted into a standard international representation. So why we want to use the interoperate tools to achieve this a solution to this problem? Because our tools can provide a translation and conversion for the foreign ACP healthcare professionals and patients. And thanks to these translations and conversions, we can allow the interoperability across the hospital of each European country. And in the end, our tools, as already mentioned a bit by Gabor, can allow better research data sharing because they are able to provide data in a common international format. So our tools are knowledge-driven. What does it mean? It means that are based on a set of multilingual knowledge resources that basically are a set of concepts describing a different aspect. For example, the concept describe the set of concepts describe the definition of the health record following the FHIR data standards. They describe all the different codes included in several medical standards such as ICD-9, 10, SNOMED, CT, LOENC, and other medical standards involved in the health records we want to manage. And also a lot of terms defining the medical terminology adopted within the health records. Thanks to this set of concepts that in our system we call the knowledge base, so an underlying knowledge base, the tools can exploit this knowledge base in order to provide mappings between the health records defined locally and defined using local format and the health record defined with an international version using FHIR. A mapping between the local medical codes and the relative international standard representation, a translation of the medical concept in other languages, and in the end also the tools are able to extract medical concept from a piece of text reported in the health record expressed through natural language. Thanks to the knowledge, we are able to perform all this operation. Now I'm explaining you just a brief introduction. Sorry, Tino, if you can pause the video. Okay, I'm going to present you through this video a couple of two of our tools that are used by a data scientist in the hospital. The data scientist has to have the experience in this kind of mapping procedures, data mapping procedures in the conversion and translation, and of course he has to have the experience in the medical domain in order to understand the meaning of the data he wants to manage. So the first tool I want to show you is the knowledge management tools, because this is the tools that we use to collect, manage, search and explore the knowledge we collect in the what I call the knowledge base. So okay, we can start the video, Tino, thanks. So first of all, I can show you an example of the codes of the concept we collect in the knowledge base. It is an ICD-9 code that is associated to the ICD-10 because these two concepts have the same meanings, so they are connected in the knowledge base. We can express the description of this code also in other language, for example, in Italian in this case. And another example of concept included in our knowledge base is the FHIR attribute related to the FHIR resources we want to use to represent our data. For example, here we have the representation of the observation, one of the resources we want to manage, and we have the concept related to the subject, the patient subject of the observation. Thanks to the representation of this concept related to the FHIR attribute, we can construct what we call a schema for the resources we want to produce. For example, here we have a schema for the resource patient that basically is the structure of the patient involving all the different attributes following FHIR, of course. This is our international schema, international representation of the patient. Another example that I'm showing you is for the observation resource. Now, the output of this tool can be exported as an ontology, basically, that is an OWL file that can be imported in this second tool that I want to show you. That is a data mapping tool. So the objective of this tool is to map the data locally defined, for example, in our case is a CDA file, with our international schema that we defined using the previous tool. So first of all, we have to import as input the ontology, the OWL file we generated from the previous tool, and the data locally defined, here represented. Here we have an example of a patient expressed using the CDA data format. In the blue part, we have the attribute of the patient, and in the white part below, we have the value of those attributes. The operation that the data scientist can perform on this dataset is to map each attribute we need to the representation of the attribute in our schema that we defined previously in the previous tool. So, for example, I'm showing you the mapping operation for the surname of the patient. Now, in the upper part, we have this little graph involving an object that is connected to the value in the CDA format through the property we defined in our international schema. Another example is provided also for the name attribute of the patient. And as we will see, there will be a connection of the same object, because we are talking about always, we are talking about the patient, connected to the other attribute in the CDA representation, as you can see now in the little graph above. We can perform, the data scientist has to perform this operation for all the attributes he needs to map, he needs to manage. So, for example, here also for the telephone number. And the mapping operation are not the only ones, the only operation that the data scientist can perform using these tools. He can also extract concept, of course, collected in our knowledge base, as I described it before, from the word of the dataset. So, for example, here we have the word male, describing the gender of the patient, and the data scientist is going to extract all the concepts in our knowledge base describing the word male. We have several in the new column, the brown column I'm showing you. We can explore each concept extracted through the previous tool I showed you before. This is exactly the previous tool. We have a direct link to explore this concept extracted in order to choose the best one for the mapping operation. All the operations performed using this tool are listed here in the left part of the screen. You can see the list of the operation. We can also decide, for example, to delete one of these operations if we recognize that it was wrong. For example, here I'm deleting one of the mapping operation, and in the screen will not be available anymore, so the link has been cancelled. And we can also, most important, decide to export all the operation in an object we call the data mapping model. So this model will include all the operation performed on the dataset. And we can decide to reapply a model, a mapping model, on a different dataset, of course, of the same time. So we can, as I'm showing you right now, we can decide to reapply, upload again the patient dataset and reapply a model already existing involving several operations. For example, here I'm showing you the application of a model involving a lot of mapping operation, concept extraction, and data management. This is a very useful feature because, of course, we can perform this operation on automatically in one shot without performing all the mappings attribute by attribute. We can, in the end, export the output of our work, that is the dataset connected to the mapped through the international schema we defined. And in the previous tool, the first one I showed you, we can see the result of this mapping. So the value of our patient expressed through the fire attribute, connected to the fire attribute we mapped using the data mapping tool. Another example also for the observation results here. So thanks to the this mapping operation, thanks to the knowledge we collected, we are able also to translate, because the knowledge resources are multilingual. Tino, if you want to back to the slide. Okay, we are able to exploit our knowledge that is multilingual also to convert and translate. Here I'm reporting you an example of some information regarding the patient defined locally in the upper part in the yellow table. We have some information expressed in Italian and using also medical standard used only in Italian. And in the blue table below, we have the international version of this information. So after translation operations and conversion operations. So for example, in the case of the primary condition, the code that was expressed in ICD-9 in the Italian version has been converted using the international standard ICD-10. So next slide. Okay, so to conclude, which are the advantages of this approach? So as I showed you in the demo and the video, we can reapply automatically a mapping already generated, so we can do it just in one shot without performing step by attribute all the mapping operation. We can not only, because we can do it on a huge quantity of health records. So for example, in the case I showed you in the video, we can perform automatically that operation on a huge quantity of patients, for example. And most important, we can exploit new standard or terminology or languages, just updating our knowledge base, so our set of concepts. So if, for example, in a new medical standards will appear in the next years, in order to exploit and to use be able to map our data on using these new standards, the only things we need is just to update our knowledge base, importing the concept related to that new standard. So the final consideration is that all these operations, all the usages of our tools are based on the knowledge. So the data scientist in charge to collect the knowledge has to define high quality, because from an high quality of knowledge, because from an high quality of knowledge depends the high quality of the mappings that he can perform, and of course this causes in the end an high quality on the conversion and translation operation. So the collection of knowledge and the mapping operation are not just an operation that is performed in the beginning, but is an iterative, a continuous process performed by the data scientist in order to improve the power of the knowledge base, the underlying knowledge base. So I'm finished. This is, of course, a very short and quick presentation of our tools, and if you want to have more details, you can also ask for a private connection in order to explain better all the usages and details about that. So thank you very much.
Thank you very much, Simone. It's time for question and answers, but I would suggest to move to the panel and include all the question and answers into the panel discussion, if it's fine for you. So
sure.
For the next session, which is already the panel, we have the privilege to have 5 experts from different countries and different backgrounds. The session will be facilitated by Vincent Koenen. So I hand over to you, Vincent, to start the panel discussion.
Thank you, Tino. May I suggest that all panelists activate their camera, so it will be better for everyone. Thank you all. I will first quickly present our panelists from left to right. So we have Maria first, who is from the University of Portugal. And the reason she was invited is because she's working on a related project, a EU-funded project called Smart for Health. Then we have Marta. She's representing the hospitals. She's an IT clinical application manager in UPMC, which is a Pittsburgh University, but the Italian branch in Rome. Then we have Christoph from Germany. He's from Gematik. I don't know how to pronounce that. Maybe it's a bit different in German. Christoph is from an eHealth Competence Center. He's also responsible for various cross-border services and so on, HL7 standardizations. Then we have Ernest. Ernest is a doctor, but he's working today at Cerner, which is an EHR, so electronic health record provider, hospital software provider. He represents that industry. Then we have Frédéric, who is the CEO of an imaging startup based in Belgium. They offer both open source and additional professional services related to medical imaging. He's representing the app and startup world. And finally, we have Giorgio, who is part of standards. He's representing standard development organizations. He's working for HL7 Italy and for various cross-border projects. He's also an expert on international patient summary. Voila, very quickly, this is the panel that we have today. Thank you all for contributing. Before going to the questions, I would like to insist to all participants that you read the first line of this slide and you use your smartphone or your computer. You go to menti.com, you use the code that is displayed there, the 7 numbers, and you will be asked 2 or 3 questions. So please go there, and while we have this panel, answer the questions, and we will see the results of that quick poll very soon. So I will open up the panel by asking a first question, and maybe whoever from the panel wants to answer can answer. I won't ask the same question to everybody because we're a bit short on the schedule. But the question is, what is your impression of what you heard today? A very global question. Are we moving in the right direction according to you? What is your first feedback? So if 1 or 2 or 3 of you want to answer this question, please take the mic now and answer that question. Yes, okay, Ernest, go ahead.
Yeah, I think you are moving in the right direction. Cerner is not just an EPR or hospital electronic medical record. We started with what we call the population management tools 5 years ago. Well, in 2016, we started with the Commonwealth Alliance in the States to connect all the systems in the United States. Now we have 19 million lives connected in the UK, and we started in the Nordics. And we've been using the FHIR standard since then. So yes, you are in the right direction. At least it's the direction we've been moving from the last 4 years. So hopefully this is the right direction.
Thank you, Ernest. Any other comments from the panelists?
Yes, if I may add a word. Besides the technological aspect to use FHIR or some other standard, I believe that to focus on the patient-mediated data exchange is important, because I believe it's the real future for allowing the exchange of data across the different countries. And what I really would like to learn more, but maybe we have other chance to learn this, is to learn more about the semantic mapping, the transformation, and about also how the data trustlessness is assured, and how the purposeful use is actually conveyed and managed by the receiving partner. But as I told, I think that maybe you have already addressed it, and maybe next time you will be able to explain wider how these challenges has been faced.
Okay, thank you. Anyone from the panel? A quick impression.
If I may add, so from the startup perspective, also from an open source perspective, so Osmis is the reference implementation of the DICOM standard. So we have a piece of software that is called Orthanc, and we believe that the standards and open integration, open interoperability really is the future for high quality healthcare. and sometimes, there's still need for more openness. And so I definitely believe this initiative will help in this, in documenting the standard better, in having something that's basically giving an additional trust on which we can rely to have cross-institutional interoperability. So I would like to, well, thank you for the work that's done so far, and I found it very interesting to see.
Thank you. So if there is no more comments, general comments, I will move on. I will ask Tino maybe to display the current poll, how it's working. So as a reminder, menti.com and the code that is there up at the first line. And so the first questions that is being asked here is, as a hospital CIO or national or regional health infrastructure manager, would you be prepared to integrate the Interoperate services in your systems? And as you can see, a lot of them don't know the answer. A few of them are not interested. A few are as soon as possible. Probably there are other priorities, and in the coming years for of them, yeah, for maybe 20% of the population. And then the second question, and we might come back to this when more people have answered, but what main word comes to mind, what main idea when we talk about this subject? And here I don't see a clear leader yet, so there are a number of words. Yesterday we had a very clear focus on security. Now policy is getting out, so please continue to vote there. And while we're looking at that screen, I will ask maybe a few more targeted questions to the panel. And maybe Maria, if Maria, you don't have your video on, I don't know if it's possible for you or not.
I'm sorry, I tried to connect it, but I'm having problems with my camera. I just restarted, but the problem remains. So I will keep only with the mic because I cannot connect the camera. Sorry for that.
Okay, great. So I will ask a question to you then, as part of that Smart for Health project, which are some similarities with Interoperate. How do you see the two projects? Do you believe they compete on some elements? Do you believe they complement each other? How would you see that those two projects can give results and maybe collaborate or work together?
Yeah, thank you for the question. Actually, I think that although they were the two funded projects in this call in 2018, so I don't see them definitely as competing projects. I think that actually the projects funded sets of social support, they have a very complement approach, let's say. So I don't know how many details you know about Smart for Health, but the structure that you proposed with the citizen having this EHR on the mobile phone is totally different approach from the one that we are pursuing, let's say, in Smart for Health, which is more based on a central platform where the EHR are stored and then are shared with the healthcare provider. So this main difference, let's say, poses the project into two positions that I see a lot of complementarities in both of them, and not competing in any way. Of course, there are some touching points. Of course, there are some functionalities that we can say that they provide similar functionalities, but the way that they are implemented is different in that way. I had an additional question that maybe I can do right now, which is related. I saw in today's presentation that one part that you are considering as a next step is the possibility for the user to share data that he wants to share with a healthcare provider. I presume that even for the data donation for research, you can also think about that selection of data. And and I'm asking this because we are actually discussing this in Smart for Health, is how do you see the problem of not losing the meaning of data when the citizen is actually selecting what he wants to share? So this is something that we are actually discussing in Smart for Health at the moment. So if we leave to the citizen the power, let's say, to decide what he wants to share, how we will make sure that he's sharing the right and meaningful data. So it's just a question that I leave here if someone wants to comment on it.
Okay, thank you. I don't know, Marta, do you have an answer for that, or do you have a comment?
We have the video.
Well, we can hear you, I believe.
Can you hear me?
Yes.
Okay, okay, perfect.
So Marta, maybe I could ask you another question then, if we don't want to continue to that subject too much. As a hospital IT manager, you probably have many priorities, very urgent and critical things to do inside, requested by the teams, the doctors, the nurses. For a project like Interoperate to offer its services through your IT, what would you like? What would you ask a consortium like us to do to augment the chances that those services, interoperability service, are implemented in your hospital, because they come with a cost, obviously, right? So, how would you say that?
Okay. Well, thank you for the question. I think about this current situation regarding the multitudes of software are used inside of the hospital. I think it would be very complicated. Surely there is a need to go to interoperability, but from a technical point of view and culture one. I think that today is very much fragmented, and I think that, of course, it's necessary to use the current technology of data anonymization in compliance of the GDPR, and it's necessary focused on deliveries. By respective three conditions for the changement, in particular specific perimeter, user friendly, quindi application user friendly, e agile spread. I think that this project is very complex, but so I think that you should start working on a specific perimeter. For example, I think rare chronic diseases. For example, we can imagine a person treated with anticoagulants that could be identified at European level, with the possibility of an immediate interaction, okay, and allow to share the clinical condition between a foreign hospital and the national center of reference. So it's very, very interesting.
Okay, thank you. Yeah, that's always a question of priorities and urgencies and cost, obviously. So, Christophe, what would you say about this being part of maybe a national or regional program there? So you have maybe a different point of view on this, or do you think that's some kind of European enforcement or suggestions or directive from the Commission would help there? What is your point of view on this?
Yes, thanks for the question. Can you hear me?
Yes.
Okay. Yeah, it's of course a valid question, and we saw this in the 2 days interesting approaches to different architecture elements, and we saw some solution elements which are more like software prototypes, I would say. And now when you ask the question, how could this be brought forward, and then you mention, of course, it could be a European idea, but there I have to disappoint you in a way, because there is no way that a European solution can be brought to all the countries, because this is just on the autonomy of the countries in the healthcare area. So I think the way is a different one. The way is more to go and create consensus among the people who can implement such a solution, and among the governments and agencies who are responsible. So there's still a piece of way to go from your project, where you have an architecture and you have some solution elements, to go towards specifications that can be used in a tender, or can be used for a country for their own development if they decide to do so. And how to come to such a kind of specification or standard in the end, if you will, because you're creating a consensus among all the countries, you're creating kind of a standard. And there is still some miles to go, I think, for the project, that the results that you have here in the project should go to some organizations that really can create standards based on them, and then those standards may be used for tenders or for countries' own developments. That is
that's more the dissemination part you mentioned, right?
Well, call it dissemination or what. It's the way from the project results to an implemented solution under conditions of public procurement, I think.
Okay, I see what you mean. So that's interesting that you mentioned that the European Commission cannot impose that much on the countries. And there I would like to ask Ernest. Ernest, you're part of Cerner, which is very active on the American market too, right? And I believe that like 5-6 years ago, there were some constraints imposed by at that time, the Obama administration, right? Imposing all hospitals using EHR software to use FHIR or standards compatible software. And that has, in my understanding, created a huge progress, a huge step forward in interoperability, because, for example, like a personal health record like we developed is compatible with 85% of the US hospitals, while in Europe it's still a huge challenge because there is no imposed upon standard, right? As Christoph said, it's hard to do legally, at least. So what would be your take on this, Ernest, and in comparing maybe the US and the European approaches on this? And please unmute your mic.
Sorry, thank you for the question. In the States, it went absolutely the other way. Obama did not impose any standard. Obama asked the market, the companies, to agree in a standard, because what they said, the government said, if you are not interoperable, you cannot contract with the government. So we were the companies moving and joining HL efforts or HIMSS. And we got disagreement on deciding that FHIR was the good one, because the way the government regulated that was not at the IT level, but at the funding level. So if you want to stay in the market and contract with Medicare, you have to be interoperable, which is quite empowering people instead of empowering the companies the other way. The other main thing is that hospitals and healthcare understood that this is a serious thing and it needs to be done fast and in scale. This is not about prototyping. This is not about small things doing in little patches, people trying to do little things. It's a country commitment. Although the borders in the States from different states are harder than in Europe. It looks different, but it's true. For instance, you cannot practice medicine in another state than yours, which in Europe we can go, and if we speak the language, we can practice in another place. So the main thing is that IT and interoperability and electronic medical records are part of the continuum expenditures. We've been found in Europe, especially in the South, that for the last 5-6 years, we tried to fund things that in fact are current expenditure based on European funding for investment. And that's why it's limiting to pilots. And that's why it's limiting to small companies or small initiatives or regional initiatives instead of buying what is already set in the market. Companies like Cerner are able to deliver. And that's why we see that now in the UK, which unfortunately they're leaving the European Union, but they already have connected 20 million people lives. This is already, and they are using Fire and Smart, and Apple is there sharing their medical record in the phone. And this is this technology you have shown. And this is already in the market. It has been in the market for the last 5-4 years. So that was the point, is thinking big and allowing the companies to do their job.
Thank you, Ernest. Time is going fast. So maybe a quick last question to Frederic and Giorgio. Frederic, as a startup, small company with obviously limited resources and so on, what would be a motivation for you to implement the services like Interoperate is offering? Would it be regulations, strong relegation, or would it be state imposed, like Ernest mentioned, or would it be a competitive advantage? If you could just, in a very short answer, let me know what do you think as a startup you would do?
Okay. Well, our view on things is definitely very much driven by the medical imaging aspect of things, and so more specifically, all the AI-driven clinical workflows that use medical imaging, but also other data in their workflows. And we actually have identified 2 trends that are coming up in terms of interoperability when you're talking about AI-driven clinical workflows. Is the first, we're moving from a very static way of looking at things. You take a picture and you can correlate that to other data, to a more predictive AI model and also AI-driven patient companionship. So they're actually taking other information than only medical imaging information, and so there's a need for access to that. And also in the need to better specify objectives when adopting AI-driven workflows, you need access to a lot of KPIs in order to know whether the solutions that you implemented are actually having an effect on the performance of different metrics. And so these 2 trends greatly knock up the need for access to non-imaging structured information in order to extend the range of data that you can correlate, and that you can make correlations on. And so as a consequence, and also taking into account what was being said by Christoph with regard to a common adoption within the EU, having access to a solution that drives access to data in a standard, open, and secure way is definitely key. And this project seems to enable that, so I can only encourage it.
Okay, thank you, Frederic. And I will conclude maybe this part of the panel, then we can, if we have time, open up the questions to the audience. But Giorgio, would you agree to make a final comment as member of the panel here on how do you see those standards issues, like the one we use in the project, Interoperate project, like what is being done in the US, as Ernest explained? How can you have a final comment on those standards in various continents, I'd say, and how they should be imposed or not imposed or market driven? Or can you make a final comment on that, please?
Vincent, before Giorgio answers, can I add just an answer to the initial question of Maria? Maria was asking how we can assure that the patients share the right data. The answer to these questions actually depends from the scenarios we are talking about. If we are talking of research, in the case of the Interoperate protocol, the the research organizations shares an machine interpretable description of the data that are required by their research study. So the patient have just the options to choose if to share the requested data or not. The patient does not choose the data to share. He can accept to share the requested data or not. Then the request is interpreted automatically by the SERAP that share the required data if the patient gives the consent. The situation is different in the medical, in the healthcare scenarios during a medical visit. Of course, the situation in this case is the same that you have when you encounter face-to-face your physician. Your physician can ask you something, you can decide to not answer. So in the same way, a SERAP can give the possibility to the citizen to hide some information. Of course, this is at risk of the health of the patient, but this is something that always happens. The patient can decide to hidden something. But in the case of the research, we don't have this risk.
Yeah, thank you. Maybe this type of questions can be answered together as a follow-up questions. So we will probably create some kind of Q&A for all the questions that have not been answered. And so all of those additional questions can be answered. But feel free to send them by email or in the chat today. And then maybe Giorgio, if you remember my question, or shall I repeat? Yeah.
I can try to reply. Yes, I mean that I believe that the choice that has been taken by the project in terms of referring to FHIR and in particular also to look at the IPS, I think is a choice that goes in the right direction. It's clear that the IPS provide a way to exchange a minimal set of data, and this ecosystem of standard need to be increased when you will have more detail or more data that you need to exchange. What I would like to highlight is the fact that I believe is the right time to bring the contribution of this project together with other projects that we have, for example, the XCL project or other projects, and try to contribute all together for the creation of of European Argonaut or European IPA standard in order to define a common set of building blocks that could be reused for different purposes. And in that sense, I really invite you to join the IPS community and try to share your experience, and also to join the XCL community of practice that try to take together all these different initiatives in order to promote this kind of standardization at the European level.
Thank you, Giorgio. And for specific information about this project, we have the website and a mailing list, right? A newsletter. So feel free to also go to the website, interoperate.eu. Interoperate is spelled with EHR in the middle, right? It's a play on words. You can search it on Google, and then you go to the website and register for a newsletter so you can be informed on that. Stefan, Tino, do we have time for one or two questions from the audience, or are we a bit short on time?
Thank you for asking.
I think I catch that from the late from the previous ones, but still.
I think, thank you, Vincent, for managing the panel. We are very well on time, at least better than yesterday. And actually, I see no compelling question coming up right now for the panel. So I would suggest that we hand over now, or we come to the next phase, which is a wrap up and next steps. And here it's a pleasure to welcome once more Dr. Carrie Thompson from DG Connect, Deputy Head of Unit ES Wellbeing and Aging. And she already presented yesterday what's currently ongoing on the European arena. And we had in the panel these interesting observations on what could be, let's say, imposed by Europe to the member states, and we heard of the market approach in the US. So maybe this could be some of the elements that Carrie would like to touch upon. So your floor, Carrie. You have to unmute your mic.
Thank you very much to everybody, and thank you very much again for another very interesting morning. I've learned a lot listening to you, and what for me I think it's been clear. I have a very positive sense of the work the projects are doing, as well as on the community around the project, which I can hear and listen is engaged and positive, and the way in which you're reaching out to other parts of the ecosystem. I think it's very encouraging. Yeah, in order to close, some closing words and what comes next. Well, specifically for the project, we've asked your project to give a presentation at the next meeting of the eHealth Network, the member states meeting, which is a voluntary network that's with the mandate, of course, to oversee digital health activities, cross-border digital health activities in the EU. And we started a while ago a session where we bring interesting projects in front of the network, and this time we'd like yours to give a brief summary and to explain what the project does. And I think, to go back to the discussion about the US versus the EU, this is absolutely correct that the EU is founded on different principles. The relationship between the EU and the member states is different to the one between in the US at federal level versus state level. And that influences, of course, what we're able to do. And as far as health and care systems are concerned, the member states are the key and critical actors who remain the key decision makers in terms of the financing and the priorities and the policies for their health and care systems. And then the difference doesn't stop there. It's also around the nature of the healthcare systems as well. In the EU, the health and care systems are very much based on joint risk sharing. They're publicly funded, based on sort of principles around, clear equity and fairness. In the US, it's a different kind of system. It's largely a private system. So one of the impacts of that is that you need, in many of the countries, which is not the case in many countries in the EU, but you've set up the electronic health record systems largely for billing and for helping with the payment system. So they have a very much more kind of fundamental role in their health and care systems to make, in terms of the governance, the financing, and making it function. Whereas in many countries of the EU, if the health and care systems are financed through on the basis of national health systems, there isn't a billing mechanism. It's always free at the point of delivery. So you don't need this. The systems are really only set up in order about managing patient information. Originally, they were set up to help manage, hospital processes, but now we're trying to make these systems broader with a bigger role, and to try and use them as, mechanisms to capture information about the patient experience that we can then take up a level, and we can share with the patient, or we can combine with other parts of the system and create, large databases of electronic health record systems. So there's so much that's different about the US and the EU, and it's partly the relationship between the centre and the member states, and it's partly the relation, the fundamental principles on which the health systems are formed. So, in going back to the discussion about FHIR, the member states are certainly very aware of these kinds of options and discussed it amongst themselves. But then they're up against themselves that making the right decision for their country as well as the right decision for the EU digital market. And then, of course, in some healthcare systems, there's a further issue that they're very regionally organised. So the person who may come to the eHealth network then, has a role to go back and disseminate to the regions. But certainly the member states in the EU also have a similar set of tools. They're able to influence in their own way. They can set legislation around the health and care system. They can incentivize through the use of funds that come from the central or regional healthcare system. So I think once the decision's been made to happen, making it happen, they've got plenty of tools. It's then about, what is the best technologies to bring into the system. This is, I think, where the discussion is in relation to FHIR. So, I mean, more broadly then, of course, this meeting I think will be very, very valuable for the project, because you're talking to the member states at this point in time, which is a critical point in time, because of course COVID is still ongoing, but we are beginning to go back to these discussions in a more sort of deeper way. Plus the fact that from next year we have the work, the multi-annual financial framework kicking off, and of course I mentioned it yesterday, but we do have the picture in terms of funding available in member states and across the EU for digital health is really going to become very large indeed compared to what it's been in the past. I mean, not only we continue with the funding on Horizon, which is funds your project, of course, but this is our innovation tool. But then we're adding the Digital Europe program, which we see as the deployment program. So where we've had, where we get the proof of concept in Horizon, we then intend to use Digital Europe to start to deploy, as well as EU for Health is another entirely new program with a large chunk of money that will go towards digital health. And in a way, these are a little bit even dwarfed by the Recovery Resilience Fund, which is this new fund I mentioned earlier, which the funding has derived along new lines entirely linked to the pandemic, where Europe is allowing the Commission then to do its own borrowing from the markets. And what the Commission is putting shape and a framework on these funds and how they'll be used by member states, and saying that the twin focuses should be digital and green. Because it's not just about recovering from the pandemic, but it's about simultaneously using the funds to kind of propel Europe into the future on digital and green aspects. So, as I said, I think yesterday, we think that there's an estimated 20% of these funds should be reserved for digital, which makes for over 100 billion going for digital funds across the EU over the next 6 years, just from this fund alone, plus the other funds. So I think we're looking at, I think we're going to see a lot of action over the next 5 years, a lot of funding, and of course it's all going to rely on the new technologies that were coming on board, new proofs of concept like the kind of work that your project's doing. We look to member states to look across the landscape in different areas, in the different pieces of the jigsaw of the European health data space, and to look for what the solutions are available that appeal to them. And so this is where I think you have a chance to make this clear statement about what your project's doing and what the appeal is to the member states in the coming weeks. And then more broadly, I think of what relevant to the project, I think you may be aware that there's an ongoing review of the regulatory framework around eIDAS, and whether or not this is still fit for purpose, and the Commission intends to come forward with a report on that, which, therefore, if it contains reference to it not being entirely fit for purpose, there will then be, I think, proposals for how to strengthen it. Also, in terms of on the other side of things, the Commission, I think, will shortly come forward with the Digital Governance Act, which is following up the data strategy, which will be looking at health data space as a priority, and what member states need to do next to strengthen their legislative handling of national data spaces. And then I think in 2021 we're going to see more bases being laid for taking forward the European health data space in terms of infrastructure, but even further legislative aspects around, for example, health data sharing, or linked to the secondary use of data, and so on. So it's a very active policy picture. You're doing your work at a very exciting time, I think. Like you, I think we can all look forward to seeing how this will develop in the next year or two during the life of the project and beyond. So that's all from me. Thank you very much again for the invitation.
Oh, yes, thank you for this really inspiring insight, and bright perspective to the future. So, and also a lot of encouraging messages, I think, to our project coordinator. And I pass on the last word to Matteo then. Thank you once more, Kerry.
Yes, thanks a lot, Kerry, for your words, and this for sure give us an additional push for these remaining 20 months, if I do the right calculation. And for sure, we know that a lot of work is still in front of us. What we have seen today is just a first test of what we expect to deliver at the end, when we will also test in real settings what we have done, to see if they then work on with the patients, healthcare professionals in a real setting. So, and the other thing that I want to say is that, as I said, this has been 2 inspiring days for us, because we received a lot of questions. We have established a lot of potential contact that I expect will be kept alive along the remaining months till the next final workshop we will organize by the end of the project, in order to exactly see what we are producing and keep us always in tension in order to be sure that we are really going in the right direction, as I think that we are doing, because for what I heard from Kerry yesterday and from all the other comments, I think that we are on the right direction, always having in mind the European dimension, because we are working in European dimension that I strongly support. What just said is different from the USA one, which is a completely different market, completely different context with respect to what the European healthcare system works and how each member state works in its independent way to manage healthcare. So just to close, as we are running out of time, I would like to thank every single participants to this workshop, to the panelists and to the organizer, so my partners and colleagues that organized most of the work, because I did very little, I have to say, with respect to them. And I also thanks those that intervene and all the questions that, as I said, I hope we will be able to answer in the next weeks online to each one of you. So thanks to everyone, and I hope we will be in touch in the next month.
Thank you. Bye-bye.
Thank you, then.
Thanks, Kerry. Thanks to everyone. Bye. Thanks a lot to you. Bye.